Hey guys, Dr. Brown with Kubo Math coming to you from Tarlac City, Philippines, and tonight it's 5th and 6th grade. We're going to combine this session because they're both working on similar items and fractions, but we will not do fractions tonight. But least common multiples and greatest common factors. I think there's still some confusion, and we're going to work one problem with each, hoping to show you the difference between the two. Okay, so let's get after it. When you think about, let's say, the multiples of 5. Multiples. When you look at your multiplication table, you have 1, 2, 3, 4, 5, 6, all that across the top. And then 1, 2, 3, 4, 5. So let's say you have the number 5. So you have 5. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. So you end up with 5, 10, 15, 20, 25, 30. Those are multiples. Multiple. You're multiplying. It's multiples of 5 or multiples of 4, multiples of 3. 3, for example, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. So 3, 6, 9, 12, 15, 18, so on. 21, 24. Those would be multiples of 3. So when you think about trying to determine the least common multiple between two items, you're trying to understand the least number that's in both of these rows. Let's take two examples here. Let's think about 12 and 18. Okay, so let's divide both of those by 2. This is a method called prime factorization. So 12 divided by 2 is 6. 18 divided by 2 is 9. So let's use 3 into both of those. 6 divided by 3 is 2. 9 divided by 3 is 3. So now let me continue with the 3. I can't divide that evenly into the 2, so I'll just bring the 2 down. 3 divided by 3 is 1. Okay, now I'll do the 2. 2 divided by 2 is 1. Bring the 1 down. Bring the 1 over. Okay, now I can multiply these together. 3 times 3 is 9. 2 times 2 is 4. 9 times 4 is 36. So it says the least common multiple between 12 and 18 is 36. So if you think about that, the multiples of 12, 24, 36, 48, multiples of 18, 36, whatever the next one is. So you can see the least one here would be 36, which is what we equated to. And it's just when you take 18 times 1, 18 times 2, 18 times 3, 18 times 4, and then this one was 12 times 1, 12 times 2, 12 times 3, 12 times 4, and so on. And then you're trying to find the least number that's common. Common means in both. The least in both number. That's what you're looking for. And that's the least common multiple. Okay, now the greatest common factor, we'll just stick with 12 and 18, I guess. The least common factor would be if I did a prime factorization on just 12. So 2 going to 6 times 2 is 12. 6 divided by 2 is 3. 3 divided by 3 is 1. Bring the 1 over. Do the same thing with the 18. Okay, 18 divided by 2 is 9. 9 divided by 3 is 3. 3 divided by 3 is 1. Bring the 1 over. So now, greatest common factor. These are the factors that make up 12. Because I have 2 times 2 is 4. 3 times 4 is 12. 12 times 1 is 12. These are all the prime factors that make up 12. And this 3 times 3 is 9. 9 times 2 is 18. 18 times 1 is 18. These are the prime factors that make up 18. Now we're asking ourselves, what's the greatest common factor? So I have a 2 in both of these. So that's 2 times, I don't have any more 2's. I have a 3. I have a 3 here. They don't have to be in the same row, just as long as they're somewhere in the column. So I have a 3 and I have a 1. So 2 times 3 is 6. 6 times 1 is 6. So the greatest common factor between 12 and 18 is 6. Now how do we use those? What do we do with them? Okay, I have 2 problems I want us to work. All right, let's read this one. We have a light that flashes every minute and 15 seconds. And another light flashes every minute and 40 seconds. If both start by flashing at the same time, how much time elapses before they flash together again? Now, how many seconds are in a minute? 60. So we have 60 seconds plus 15. So that equals 75. And this one is 1 minute plus 40 seconds. So we have 60 seconds plus 40 equals 100. So one of those lights is that, if they both flash at the same time, 75 seconds later, this one's going to flash. This one is going to be 100 seconds. And then this one's going to flash again in another 75 seconds, which would be 150. And then it's going to flash again at 75 seconds again, which is 225. And then it's going to flash 75 seconds later, which is going to be at 300 seconds. Now this one flashes at 100. It flashes again at 200. It flashes again at 300. So you can see that they don't flash again the same time until here. So a person could understand that if they just understood the least common multiple, because this is 100 times 1, 100 times 2, 100 times 3. It's the multiples of 100. This one is the multiples of 75. Least common multiple, because these go on forever, but what's the least one? So 75 and 100. So we just solved it to be 300 manually. Let's take and do this with prime factorization. Here's 75 and 100. So 5 would go into that 1 time 25, 15 times. 5 would go into 100, 20 times. 5 would go into 15 3 times. It would go into that 4 times. I'll do a 3. 3 divided by 3 is 1. Bring the 4 down. 2, bring the 1 down. 4 divided by 2 is 2. Bring the 1 down again. 2 divided by 2 is 1. Bring the 1s over. Now then, 5 times 5 is 25. 3 times 25 is 75. 75 times 4. 4 times 5 is 20. 4 times 7 is 28. 29, 30. So the least common multiple of 75 and 100 equals 300. So we didn't have to draw the scale. We could have said, wow, every 300 seconds, it's a common multiple. They're going to both flash at the same time. That's an example of least common multiple. Okay? Now then, let's look at greatest common factor. Okay, we have 3 pieces of ribbon. They have 3 lengths of ribbon here, and they're trying to cut them into some length that would be the same, whatever that length is. They want to be able to cut not the same number, but they don't want to have any wastage in any of these. So they're trying to figure out what's the greatest common factor between these 3 lengths. So, having said that, what's the greatest common factor between 16, 24, and 40? Okay, we do them one at a time. See, all right, I'll take 2 into that. 16 divided by 2 is 8. 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2 is 1. Bring the 1 over. Okay, 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 divided by 3 is 1. Bring the 1 over. 40 divided by 2 is 20. 20 divided by 2 is 10. 10 divided by 2 is 5. 5 divided by 5 is 1. Bring the 1 over. Now, those are all the factors that make up each of those numbers. So 16 is 2 times 2 times 2 times 2 times 1. 24 is all of these things multiplied together, and 40 is those multiplied together. Like this one is 2 times 2 is 4. 5 times 4 is 20. 20 times 2 is 40. Wow. Now then, what's common? Well, I have a 2, and a 2. So I'll write that down one time. 2 is common. Times, well, there's another 2. So I have another 2 here. And I have another 2. Times 2. And 2's, I don't have any more 2's. I don't have a 3, I don't have a 5, but I have a 1. Now you may be asking yourself, why do I include the 1? Sometimes when you're trying to factor something and it's a prime number, it's just that number times 1. So 1 would be the greatest common factor maybe that's in there. You know, if I had 2 prime numbers. So, all right, so now 2 times 2 is 4, times 2 is 8, 8 times 1 is 8. The greatest common factor between 16 and 24 and 40 is 8. So what does that mean? I have that ribbon that's 8. It's saying I can cut that into 2 8-centimeter pieces, and the one that's 24, I can cut that into 3 pieces. Well, obviously these were, you didn't have a tail sticking out, because 24 divided by 8 would be 3. I would end up with 3 even pieces with no wastage. 40, I could take 8, I could have 5 pieces cut into that one. So the 40 piece divided by 8, it would give me then 5 pieces. The 24 divided by 8 would give me 3 pieces. The 16 divided by 8 would give me 2 pieces. But I'll have nothing left over in any of them because I solved for the greatest common factor between those 3 pieces. And that would be how you utilize greatest common factor and least common multiple. Now before I go, I know some of you are working on fractions. The key to adding and subtracting fractions is get the common denominator and then add or subtract. You can't add or subtract mangoes and saging, bananas and mangoes, or watermelons and apples. You have to have apples and apples. Convert them to apples and apples, or convert them to mango and mango, and then you can subtract or add. So common denominator is key for adding and subtracting. Now if you're multiplying, you don't have to do that. Just multiply numerator times numerator, and then denominator times denominator. Now when you divide, how do you do division? So I have 1/2 divided by 3/4. I invert and multiply. That equals 1/2 times 4/3. I flip that upside down. Now I think you guys are looking at something like this. So you're doing that and this, the butterfly method. So if you'll notice, 1 times 4, 1 times 4, 2 times 3, okay, invert and multiply. But if it's multiplication, 1/2 times 4/3, 4 times 1 is 4, 2 times 3 is 6. Of course you can reduce that. What is 4? It's 2 times 2. What is 6? It's 2 times 3. 2/2 cancel, you end up with 2/3. So if I'm trying to add 1/2 plus 3/4, I have to get a common denominator, which you could, if you couldn't figure this out, do a least common multiple then between 2 and 4. 2 and 4. Okay, 2. 2 divided by 2 is 1. 4 divided by 2 is 2. 2 divided by, bring the 1 down, 2 divided by 2 is 1, bring the 1 over. 2 times 2 is 4, times 1 is 4. So my least common multiple is 4. Okay, so what does that mean? I have a 4 here. Well, to get a 4, I need to multiply that by 2. 2/2, which is 1, right? 2/2 is 1. 1 times 1/2 is still 1/2. But 2 times 1 is 2. 2 times 2 is 4. Plus, I already have 3/4. So 1/2 plus 3/4 is 2 plus 3 is 5/4, which is 1 1/4, if you wanted to convert that over. But that's how you need to work your fractions. That wasn't supposed to be part of this, but I know some of you are working on that right now. Okay, that's all for now. Why are we doing this? So that together we can build a better tomorrow, and do that through math. Study, study, study. Okay, guys? And I'll see some of you tomorrow. And but that's all for now, and we'll talk to you next time. Thanks.